I'm going to go over some stuff we've worked on and built at Mapsense. There's a lot of different things that we do at Mapsense, so I'll give you a little bit of an introduction. I'll show you some of the kind of the product we sell to big companies and the kind of our main focus, and also the developer site that we just launched about a month ago. Throughout the sort of at the second half of the talk, I'll just do some programming and show you and actually play with the tools that we've built internally. And so if you want to follow along, you should totally do so. You can maybe while I'm giving an introduction and stuff, if you do want to follow along, go to developer.mapsense.co and get a dev key. I think the link for it is here. So that's what it looks like. You can get a dev key if you want to follow along in the examples, but by no means required. So I want to show you a lot of things, but kind of give you a little bit of the inspiration for Mapsense.js. So at Mapsense, we are a mapping and location analytics company. So we work with very large location data sets. And so the thesis for our company is that there is much, much more location data in the world today, and that this increase in location data is exponential. So there's data coming from mobile phones, from internet-connected like sensors and devices that you wear around your wrist. There are connected cars. There are drones and satellites creating orthorectified imagery. There are smart grids creating electricity. And so all of this location data is most of it is very recent, and it affects a lot of us and a lot of the companies in the world today. Both new companies like Uber, Lyft, Tinder, OkCupid, but also even traditional companies, so like credit card companies. So these are just the kinds of things we work on. And one of the challenges we faced at Mapsense was creating an infrastructure to be able to ingest very large location data sets that are coming in real time, and then be able to provide those data sets in an infrastructure that will let you query them and also visualize them to actually understand what's coming out of these data sets. So for example, we work with some of the companies that are listed on this slide that send us very large location data sets. We ingest those data sets and we expose them back. And one of the tools, this is the team. We're also hiring. We're very friendly people. We have a head of recruiting who's gives a very tough interview. So yeah, check us out. Email us any questions or hiring or whatever. hello@mapsense.co. So one of the big problems we had was rendering big data sets in the browser. So it's cool to use D3 when you have a GeoJSON or a TopoJSON that you can load locally, like in the browser. But if you're dealing with data that's in the hundreds of gigabytes or in the terabytes, you start to run into limitations. And that comes from both like big geodata sets from these sources, but also from a base map. So if you want a full resolution base map of, let's say, like every road and river and building and so on that's in the world, it starts to get prohibitive to just do the naive thing, like load a TopoJSON and render it with D3 Geo. And so we developed a library called Mapsense.js. That's a small, pretty lightweight wrapper around the old Polymaps library, where we sort of gutted the internals and we used D3 to do all the rendering. So one way to think about this is Polymaps that uses D3 to do rendering. Another way to think about this is if you have a bigger data set than you can load locally in the browser, you should use Mapsense.js. So it allows you to use D3 with tiled vector data. So let me just show you before I go through these decks. I kind of just want to show you what you might build with this. So let's open up like the So this is a map of about 15 million different crimes that happen in the city of San Francisco. You can see that there's a histogram at the bottom for time. You can see the density of crimes, so they cluster in the tenderloin. Every one of these crimes is clickable. This is just SVG. This is all rendered with D3, including the base map. And so I can touch everything, I can interact with it, and my charts are also dynamic to the bounding box. So I can pull up a filter like category here, drill down on one of these. So let's look at prostitution arrests. And we can see that it looks like there's a big cluster in the Tenderloin and then also in the Mission. So here over the last, looks like it's 10 years of data, we can see how this, we can also see this over time and see that there's like, maybe there's some movement over where these arrests have been happening. And so this, both the base map and the points here are being served by our API, which the keys you guys might have registered. And the rendering is happening with Mapsense.js. And then we've written some custom chromes for the filters and so on. And this supports coloring and so on. And I'll show some more examples about this later. So where do I want to go next? So I'm going to go back to this slide deck and then jump into some examples in a second. But I want to give you guys a little bit of a history of how web maps work, because we've applied a lot of those concepts to what we're doing. Does anybody know, this slide make sense? How many people does this slide make sense to? OK, so like half of you. So the idea, and I'll do this kind of quickly, is that people have taken 10 years ago, the way a digital Slippy web map worked is that a bunch of geodata was stored in a geodatabase and then rendered into a bunch of images. And these images were stored at different zoom levels, and there were kind of this pyramid of images. This is called a tile set. And then those images are sent to your browser in a mosaic, and as you zoom in on MapQuest, you can see those tiles coming in. And the reason for that is because, similar to the problem we faced at Mapsense with this vector map data, you can't load the entire map in the browser at once, either in an image or in vector format. It's just too much data. And so this was a nice trick to be able to send map data to the browser. What we've done at Mapsense is basically built an infrastructure to send these similar files over in this tiled scheme. But instead of sending image tiles, we're sending vector tiles. And so there are a couple of companies doing this. So Mapbox does this. I think Mapzen is starting to do this. Our renderer, though, is based on D3. And so that's what we're going to talk about today. Are there any questions so far? I'm not going linearly, if you've not noticed. So you can ask questions. They don't have to save them for the end. So I want to show you, I'm going to just now give an example where I'm going to create a map. And I don't have the resolution to do this, so I'm going to do some copying and pasting. So let's start from scratch. So D3 is a requirement of Mapsense.js. So we have topo.json is also a requirement. Then Mapsense.js is our main library, and then we also include a Mapsense CSS file that does map styling. This is optional, but there's a lot of nice things in it. I get rid of this. Get rid of this. So all I've done here that I've copied this code is I've initted a div called myMap. And I've added a Mapsense map, passed it the myMap div, and then done this. This is a shorthand function to add a base map. I gave my API key. Instead of putting false here, I'm going to just get rid of this. So this is all you would need to init a map. So this would look like this. And let me also preface this by saying I'm not a real engineer or developer, so if I mess things up, fix them or tell me, or just don't get mad at me. So here's a map. So what this is doing, what this Mapsense base map shorthand does is it gets a URL of the Mapsense Earth data set. And so that's one of the data sets you can get here. You can get this SFPD data set by clicking on this. So this is how SFPD looks. We just pulled Mapsense Earth, which is all of OpenStreetMaps. And this is what the tile URL looks like. So you can see that this map is a vector map. So we can zoom in, we get continuous zoom. One of the things that's happening with this Mapsense CSS style sheet is we get zoom-dependent styling. So you can see roads are getting thicker as I zoom in. If I zoom out, the rows are getting thinner. And so there's a lot of things happening kind of behind the scenes. And this is a fully vector map drawn in D3 for the whole world based on OpenStreetMaps. And it's pretty performant. And I'll talk a little bit more about some of the things we've done to make it performant. But it's fast. You get 60 frames per second. The worst zoom levels are around 7, where like this combination of a big bounding box and a lot of features comes in. But even like, I think this is probably the worst. So this is probably the slowest performance. Yeah.
I don't know if this question is helpful to other people, but I was just thinking like the map that probably most of us are most familiar with in the browsers, like Google Maps.
Mm-hmm.
Could you contrast like how you're doing this to how they're doing it, just in basic terms? Is it totally different? Is it similar?
So Google Maps today is now a WebGL map. So it's become a vector map today. So the big difference in a traditional map and what vector maps is instead of sending image tiles, we're sending the raw lat-long data to the browser. We are rendering it here with D3. Google Maps is doing it in WebGL, and that's one of the differences. But the big innovation and what's happened, how Google Maps has changed and how we've changed since like 5 years ago is that we're not sending image tiles. We're sending we're sending the vector data. And so I'm going to show you a lot more of like what that means. I'll just show you, to show you what you can do with this. I can like grab, everything is an SVG element. Remember, this is D3. So you can grab these. These are all DOM elements. I don't know where that one went. And I can change the color of schools by changing this. We can also, you can see that it has a class here, school, and so you can start to do now data-driven rendering. So we can change, this is changing the schools and coloring them based on a style sheet. But let's say you have a data set of tweets and you want to color all tweets in one language, one different color. So having the vector data and on the browser lets you start to do those things. So the next thing I want to do is show you just how we can style these things. So we've built a lot of just really easy styling things into Mapsense.js. And so the style you see here is the default style. It's called light. But we have a bunch of different styles. So this one's called Tron. I think we have one called dark. What's another one? Vintage. And these are really cool. And we spent some time doing this. But honestly, we didn't spend that much time because instead we built a little tool to let you do your own styling. And so here are some like preset styles. But this is a little tool that lets you actually just change and edit the style of anything, so all the rows and everything. And then once you're done, you can grab the CSS. Let's go and put it actually like in our website. The only thing you need to do here is instead of giving a style, put a style false tag. And then so that will say use the. And so you can see like that's how easy it is to start creating your own map styles. And so this is kind of an ugly one, but let's say we want to do vintage, and then we want the roads instead of orange to be a little bit more red. So let's do that one. Did everyone follow how I did that? So the next thing I want to show you is starting to do this data-driven rendering. Actually, before I do that, I'm going to stop and go nonlinear again and go over this page and the different data sets that are on here. So the map I've been creating so far is based on this data set, Mapsense Earth. And that base map shorthand was shorthand that lets you render this tile set. But there are a lot of other tile sets here, and so I want to just go over them, but also kind of talk a little bit more about Mapsense Earth. So this is a tile set coming from OpenStreetMaps. And so we pull OpenStreetMaps every couple of weeks and render it into a bunch of vector tiles that we expose via this API. And so this is OSM, but instead of getting just you get the vector data, so you get all the buildings and stuff, but you also get the tags and all the metadata that OSM puts on buildings. So in New York, a lot of the buildings have heights. So this building is 72 meters high, and it's Cooney and Hunter College. It's a school. It's an amenity. So all this data is exposed via the API. Another data set that's really interesting is Mapsense points, or OSM points. So this is every point in OSM. We just grabbed all the points, every geometry that was a point. So this is 72 million, roughly, POIs. It's schools, restaurants, park benches, trees. I mean, there's crazy stuff in OSM. It's all here. This is also all the metadata on these points. So click on a point. You can see. Actually, we're not showing. Oh yeah. So this is raw dump of every point in OSM with all of its metadata. Sorry, you had one question then.
So now we're at the top level of this pyramid, right? So at the top level, are you doing sampling at the points?
Yes. I'll talk about it.
Okay. Same question.
Okay. Yeah. Okay, I'll go to that now. So we do a lot of things to make this quick. Simplification, I'll talk about in a second. But we do something called density sampling. And so this is a thinning of point data sets so that at an outer zoom level, you don't get inundated with 72 million points. So we're not sending 72 million points down to the client. This density sampling, though, isn't just a random sample. It's not a 10% sample of points. We actually do kind of a slicker sampling where we look at a neighborhood, look at its density, look at its neighborhood, the neighborhood around it, and understand how dense it is compared to its neighborhood, and then choose a sampling rate for that region. Then you'd go to the next neighborhood and so on. So it's a little like calculus.
So it preserves outliers?
It doesn't. Yeah. Yeah. He invented it. So. Yeah. So maybe I'll go back to the SFPD data set and just show you how it might look. So you can see that it's got its line here. And let me do another filter. Instead of doing a category filter, I'll search for text. So let's find where we can get marijuana. So you can see that the density sampling happens within your queries to Mapsense, to the Mapsense API. One of the funny things here is that different drugs have totally different spatial distributions. Now they do delivery. OK, so I want to go back to this base map that we had here, which still is kind of ugly, but we'll leave it. And I want to start, instead of just coloring things by default. Actually, I'm going to get rid of this. I hate this style. I want to build an app. I'm a developer, and I want to color all the schools, or let's say all the hotels. Let's say I'm building a hotel app. And so I want to show you how you might do that with Mapsense.js. So you guys are all here because you've used D3, and you guys are D3 developers. And the powerful thing in D3 is your selection function. And so in Mapsense.js, your selection function is maintained. We haven't lost D3. We've wrapped D3 with tiles. So I'm going to expose and write a selection function. And the way it works is that selection function is run every time a new tile comes in. Every time you change the selection function, it's run on all the tiles again. So you have access to D3. You have enter, exit, update. But it's in the context of the selection function that gets run on tiles as they come in. And so let me show you an example. And if you have questions, because some of the hardcore people now are going to have questions, I can tell. So first thing I'm going to do is I'm going to take this, which is a layer, and abstract it. So I'm going to do base map is kind of funky in that it defines a selection. So I'm gonna say I'm just going to grab that selection and then wrap it now. If you have any questions about this, ask me after. So you can see, I'm running the initial base map selection in my selection function, and now I can do D3. So I can do d.adder. Let's just make it. Let's do something fun. Let's class everything. Sorry, that's not right. So what this should do is class everything, every feature, like in every tile with this meetup class, and then I've applied some CSS here, so it'll be stroked. This is now. Can anyone see what I'm doing wrong?
Yeah, it's because you're replacing all the classes with the meetup class.
I should do this.
Class.
Yeah. Thanks. I don't need that, do I?
And that was
Yeah. I think it overwrites it. I'll give you another example. Okay. So you can start to access the elements in the base map and do stuff to them. So instead of doing this, let's actually use the features and get the hotels and stroke them red. So this is how that might look. It's actually going to be very similar. So let's leave it like this. Stroke. And I think hotels are in OSM tourism class, so I'm going to just check that that tag exists. So if that tag exists, and then I'll say if future to. Does this look right so far? Is this going to work? Okay, we got some hotels. And you might want to do, so let's do some D3 stuff. So let's do colors, and we can do. And instead of just coloring hotels, let's color everything with a tourism tag with a different color. So I can do. Does that look right?
Curly brace.
Extra?
Just extra curly brace.
This guy. Thank you. I told you I don't do this. So the hotels are there. Let's fill them instead of stroke them. And then I'm going to also do, let's apply this to everything. Dot on, mouse up. Okay, so those things are starting to come in, and I'll pull up the log, and we can see now I can click on things and see that that's a hotel, and this is a theater, and so on. So I'm starting to use the metadata in the base map and change how things are being rendered. So far, everyone following? Okay, cool. Let's just for the hell of it, so you guys can see how it looks, let's add another layer of points. So I'm going to add the SFPD data set, and let's see if we can find a correlation between hotels and crimes, or prostitution, maybe. So that would look something just very quickly like, I want to show you this because the base map function is wrapping some stuff. The SFPD data set is just, we're going to have to do all the hard stuff ourselves. So SFPD layer equals Mapsense.topo. So we support, Mapsense supports different types of layers. Topo.json and GeoJSON are the two big ones. The tiles that you get from our API are either Topo.json or GeoJSON. I think it's officially only Topo.json, but if you put a GeoJSON in there in the URL, it will give you GeoJSON. So you can, so I'm adding a Topo.json layer, and then I'm going to add a URL for that. And so I'm going to go back to my developer page, grab the URL for the SFPD dataset. I'm going to do a little magic here that you can also talk to me about later. But I'm going to just not talk about this. And then let's just again, you get a selection function for every layer, so I'm going to just class all these as SFPD. So and then I'm going to go up here and say, for everything that's SFPD, let's fill it and stroke it with white. And then I'm going to just add that to the map. And the map is drawn in this order, so base map will go below and SFPD on top, and I think I've done that all right. So we should see points here, maybe because they're white. This is the wrong, that was the wrong web page. Oh, now it's all gone. Okay, so there's and let's make it the Tron style. Okay, so here's the crimes. I've added a point layer. And I want to show you, the other reason I want to show you this is I want to show you the tiles that you go, when you get a URL from here, this is just the base URL. But we can actually, so far I've just shown you how you can change how you're rendering the tiles you're getting. The other thing that we've done, and maybe you saw how I was doing a search in the other app. I was doing search for different crime categories. I was doing free text search like marijuana. You can actually do those types of searches in the API, in the URL request. So you can say return all SFPD crimes in this tile, density sampled, or you can say only return crimes that are in this category or that satisfy this description or so on. And so what I'm going to do is I'm going to look in the SFPD data set. So it looks like we have something called category, and let's find all assaults. So it's very, very simple syntax, and where category equals assault. I think it's all caps. Let's do prostitution just because we know what that one looks like. So yeah, so you can see I'm just in the tile request. I'm doing some querying, and that's reflected in the map over here. You can see that the points are getting scaled here between zoom levels. And so that's something that you want to happen to roads in the base map, but not usually to points. And so we can actually fix that also. Sorry, I think it's, the syntax for this is scale fixed. And so you can see now points are not getting scale. And so you can see that once we had these building blocks, like the renderer that let us render things how we wanted based on the data, and then also these dynamic APIs for the underlying map data, it was very easy to get to that tool where I started to filter crimes and do things over time and so on. I had most of the building blocks actually in the API and in the renderer. And so those two building blocks are things that any developer can come and now play with on our page. So all these data sets are free and available. And also that library Mapsense.js is free as in whatever free on GitHub.
So with that last example, what happened to the tourism layer? Could you just not see it really well because of the Tron style?
I think I just hadn't zoomed in far enough, yeah. Yeah.
What about all the data? Are there limits on usage or tiers for pricing?
So we've sort of released in alpha mode right now, and so I think there's like 1 million query limits per API key. Honestly, it's something there just to make sure we don't get destroyed. If you need to hit more, email us. Like, we'll open that up for you. And then you'll have the ability to upload your own data. Right now, it's just these sorts of data sets, but that's coming shortly. You upload your own data to this.
So is that likely to change where it won't be free in the future?
Probably we'll have some model where you probably have some free tier for some space, and then as your data gets big, there'll be some cost. Yeah.
Can you go over simplifying?
Yes. Thanks. So the 3 ways that we describe we've made things easy or maps load quickly, big maps. We tile the data. For big points, we do density sampling, and then for polygonal and row data, we do simplification. And I'll actually just keep this map. Ooh, actually, it's not exposed. So when you do a tile request, there's a parameter called S, and that determines its simplification, how simplified it is. And so simplification refers to Visvalingam simplification. There's actually a really nice blocks on it. Ooh, was this it? This is the one I know. So you can see on the left, there's a bunch of data. And on the right, there's much, much less data. And so this is getting simplified. So this is a really, really simple algorithm. And so you can request tiles for polygonal line string data with its simplification factor. And so you can see that happening. The algorithm is really slick, actually. So I'll go over it just because it's so beautiful. So here's a line you want to simplify. Basically, imagine drawing a triangle between every point and the 2 points around it. Then compute the area of the smallest triangle in the line, and then throw that point away, the point where that triangle is the center point of that triangle. So in this case, you throw away triangle 5. And so intuitively, you can see how that removes the point with the least emphasis on a curve. And it's a super simple algorithm. And also you can pre-compute it really nicely. And so it's super slick. One of the things that I didn't mention, which is also for the geeks out here, our tiles are nice topologies. They're actually real topologies. And so when you start to get into simplification, when you have like at state boundaries and stuff, you want real topologies so that you actually won't get gaps between two states. Our topologies are consistent across zoom levels and are true topologies. So let me show you. So basically, when you put a URL, just play with this S parameter. I'm going to show you it in another venue just so I can play with the simplification parameter really quickly without having to change JavaScript. So this is an old version of our styler, but I mucked it so we can actually put the simplification parameter in the URL. And so you can see here some really chunky islands off the coast of Canada. And if I lower this number, these islands get less and less chunky. And then full resolution at s equals 1. Yeah?
How does it know where you should put path every time you refresh the feed?
That was, so this little, this app I built is storing that stuff. You can see it in the URL.
How about on your app, like it loads on San Francisco every time?
Yeah, that's just because so you can, let's grab this. So I'll grab the center of the map here. And I think we're playing with this one. So that's how you set it. And you can be fancy and store it in the URL or whatever, or on local storage.
Does it use geolocation for the default?
No. That's too invasive. I think I want to show you just a couple of other examples of stuff we've built internally and then answer other questions. So I just want to go, so you can go to this Mapsense examples page on blocks, and we've done a lot of different examples. So for example, creating a choropleth. The choropleth dataset is actually one of the other ones that I really love. So this is called Mapsense Demographics. We've gone and cleaned the American Community Survey, and we spent like 6 months on this. But for every census tract, census block, congressional district, county, state, zip code, we have the same normalized columns that mean the same thing across those different admins. And so unemployment, the proportion of females, all that sort of stuff. And so doing a choropleth of unemployment is literally like create a color ramp. In your selection function, style things based on that color ramp. I mean, it's very, very simple to start doing a choropleth. This tile set is also, at different zoom levels, you get finer and finer admins. And so you can see out here, it's state level choropleth. And as I zoom in, it becomes a county level choropleth. And as I zoom in, it's going to become a zip code level choropleth, and then a census block group choropleth. And again, I mean, it's like literally like a line of code to do that. One of the other interesting ones that I wanted to show you is the interactive legend. So this is another data set that's also available on the developer page. Where is it? And so this is the 5-foot elevation data set that the city of San Francisco publishes. So this is contour lines every 5 feet. And we made a little cool interactive legend here. So you can grab a different elevation, and it'll actually grab the map. Again, with D3, and since you have all the meta and vector data, it's really, really easy to start doing stuff like this. You can see the main line of code to do that here is we're classing everything with a quantile for how high it is, and then coloring based on elevation, and then the legend does the selection of that quantile. I mean, it's really simple stuff. There's also some more advanced things that you might be able to do. So where's Elon's? Don't look. Where's Elon's? Sorry, I want to find a really cool example for you. So this is an example where we had a customer who, I mean, there's a couple of reasons to do this, but let's say you have a county where you have some user data and you don't want any one user to be an outlier that takes over that whole county. So let's say you're coloring counties based on the average of the users in those counties. So let's say the average number of Twitter followers for the users who fall in that county. But let's say there's a county where you only have 10 users, and there's one guy on there who's super famous. So that county is going to really come up real big in the choropleth. So we want to merge counties that are next to each other such that there's at least a minimum number of users in that group. In this example, we're doing it based on area instead of another metric, but you could do it on any other metric. And so you can see on the left, this is the original counties colored by area. And as I move my mouse to the right, I'm doing a merge on the client here so the counties get closer and closer together in size. And so here, almost all the counties are the same exact size. Or not the counties, the merged set of counties. Some rules, this is a greedy thing. There's some rules that counties couldn't be split. You had to merge things that were touching and stuff like that. But it's really, you can see that you can start to get more advanced in the stuff you do on the client. You can also do fun stuff. So SVG gives you SVG clip path, so it's really slick. You can do stuff like this. And then you can even do, where's that? The SVG also gives you like nice fades. You can see on the border here, this is an SVG Gaussian blur on the coasts. It's actually kind of a hack. You actually have two layers. One that's just the coast, that's nothing is being rendered except the Gaussian blur, and then the layer on top of it. And I'll show you one of the OSM ones. Actually, the gerrymandering one. So we just wrote a big blog post about gerrymandering. And so this is coloring congressional districts by how gerrymandered they are. And there's lots of different metrics for how you compute gerrymandering. Like the ratio of a polygon to the area of the same size, the ratio of the perimeters, and so on. And there's a really nice blog post that Nick wrote about it. So you should check out mapsense.co/blog. We wrote a long piece about that.
So would the least gerrymandered be considered like a square or a circle or something?
A circle,
Yeah.
in that metric. I'll quickly say that our tiles can be used in Leaflet really nicely. It's not a lot of code, but you do get some things like across tiles. You don't get smooth zooms. But this is our rows on top of some MapQuest satellite tiles. This is really easy to do.
So if we want just a normal, like, if our custom class were just give me a street layer with the label streets, is that the answer?
Yeah, we're working on labeling right now, but yeah, that would be a way to do it. I think that I have nothing else to show, so talk. Yeah.
I'm just curious, if the geometry spans multiple vector tiles, does each tile have like a portion of it that has to be split? And so like there are two chunks that merge together?
Yeah, so they're actually clipped. Yeah, you're exactly right. They get chopped across tiles. And on the browser, they just look like they're touching.
Oh, they don't actually get rejoined.
So this is kind of unique to us. We actually do have information to rejoin them. We're not doing it today on the client, but we use that on the back end for a lot. But our vector tiles have the information on them to merge polygons and rows across tiles, which is really interesting. It has a lot of implications for doing distributed spatial operations. And so that's some stuff we're doing, and I'm happy to talk about it offline. But if you want to do tile-wise spatial operators and then merge the results, you can think about why merge. Yeah, it's really, really beautiful.
If I want to do like clustering of points, do you have any information about the density sampling so that you can cluster at higher levels?
Right now, we don't have anything like that exposed. The only thing you have is you can control how many points to return when you're density sampling. So you have a knob there, but there's no like metric for doing like a hex bin style clustering.
What about filtering geometry features? So if I want to set me all the points,
We do support, this isn't stuff we have released yet, but we do support those sorts of joins across different data sets. And you should see that coming. I don't think it's publicly available, but you can do filters by areas, and you can also start to do aggregation functions. So you can say how many, instead of showing this as a point data set, show it as a heat map of congressional districts or whatever. And so that's stuff we have a lot of stuff internally that does that aggregation over very large data sets.
Can I serve myself back topo.json files off my own hardware?
Sure, but we can't. I mean, I don't get your question.
Well, you mentioned that the capability for uploading files or your own geometries is not available
Forthcoming,
yet. So the Israel would want you to serve your own feature geometry. A static topo.json, yes, very easily. If that's what you're talking about. Tile topo.json, you'd have. I mean, we don't have that stuff open source to be able to like run that in tile locally. But it's very simple. I think I have a cool example of it. This is, often like loading a static topo.json. I was saying like that's the common thing to do with D3 is static topo.json file. But it's still there's a lot of stuff to do. Figure out like the projection, then figure out how big the map you want it to be, and then if you want zoom and panning, there's a lot of work to do. It's actually, so I wanted to show this, good that you asked me. Here's all the code. This is just the base map thing we showed you, and this is just loading a static topo.json that I have called SF. You don't have to muck with anything. You don't have to know the object names or anything. And you'll get, so let's get rid of the base map. So this is a topo.json. So it's very easy to get to load a topo.json without doing any magic with D3, and you get pan and zoom and figure out the projection and all that. So yeah, it's super nice. Even if you don't want to use Mapsense API, Mapsense.js is really nice.
Can you advise someone where to get these JSON or GeoJSON files? I want to get the road network of another city that I want.
OpenStreetMaps. You can get them from OpenStreetMaps. You can get them from this API and get tiles of it. We also will, coming in the next few weeks, you'll be able to get a bounding box of OSM. So it's kind of like the Turbo API, Turbo Pass. I forget what it's called. Give a bounding box, give a query, and you get back a topo.json that you can keep statically. But for now, you can't do it with tiles.
Do you guys plan to add the ability to draw on the maps, like draw polygons and markers?
Yeah, we're working on some of that internally. We may add it to Mapsense.js or as a separate plugin. But there's a lot of tutorials for how to draw with D3. So it's not so difficult. Yeah.
Are you guys thinking about sort of the terminology debate? Because vector tile, like you're about to lose vector tile quickly as Mapbox and Alex3 are starting to like define vector tile using a very specific format. So you guys have vector tiles, but it's a different data format, right? Like is there a discussion about naming, about like what to call yours that are different than the other vector? They're all vector tiles, obviously, but like they're not compatible, they're different.
So I think you can talk to Mikey after if I'm wrong, but I believe that, we're not serving protobuf tiles in this API. We do serve protobuf tiles. Even if you're getting topo.json tiles, it is still following the same spec. The difference, one big difference is our tiles are actually a superset of the Mapbox Esri tile spec. And the one big difference is that merge information. So our tiles have more information than in the Mapbox spec, but still, I think, follow the same hierarchy.
Okay, cool.
Yeah.
So
I think there is going to be, it's consolidating, yeah.
You mentioned you have a really clean ACS data set. Would that be available to download code or like a dump of that and reuse it under an open license, or is that proprietary?
Right now, it's only available via this API. Yeah. Anything else? Cool. All right.